Hello everyone, my name is Angelo and today I'm here to present you an article called Assistive Toolkit for Teaching Programming to Visually Impaired Children. The motivation of our work is related to the fact that according to the World Health Organization, we do have 2.2 billion people with visual impairment in the world, and among them there are 400 million people with blindness. On the other hand, we do have the International Monetary Funding, which states by 2030 we are going to face a lack of IT professionals, around 85 million professionals. Our strategy to face these realities is to try to teach programming to blind children, which can create a future IT force which can be more inclusive. Our proposal is to do that through defining a toolkit with pre-existing software assistive tools that can be used to facilitate their learning process. We started by a systematic literature review based on the research questions on what is the state of art on teaching programming to blind students, and do these resources really support children learn? We found 52 works returned from 4 libraries, and we had an exclusion criteria based on excluding articles not really related to learning process. Our systematic literature review pointed out that adopting pre-existing software resources to assist children to learn programming is adherent to the state of the art. And by the way, we found 3 related works which were defining software assistive tools to support children learning. Those articles were the basis to our proposal. What are the contributions of our work? We are presenting a systematic literature review on teaching programming to blind children, which is relevant by itself. And additionally, we are proposing a toolkit of free assistive software components to support software development by blind students. So we evaluated and packaged the solutions which have no cost and it can be used according to the literature review to better support the learning process. Our proposed solution, the toolkit, is based on a block programming language. In this case, we are working with Scratch, which can use custom blocks to provide audible feedback on executed commands. We are discarding, it is out of our scope, the use of screen magnifiers, as they do not support blind students because they just amplify the screen and a blind student cannot rely on it. Alternatively, a blind student needs a screen reader, and we are working with NVDA. NVDA, rather than amplify the screen, reads its content to the blind students. And we are complementing the solution with a dictation software. We are proposing Windows 11 voice typing. It is an alternative to convert voice inputs to text. It can speed up the code writing and is fully supported in English, French, and German. As future work, we intend to apply the material with students, to evaluate results, and to propose best practice. We will also develop lesson plans which can cover a full course on programming. Thank you for joining me on this presentation. It has been a pleasure to show you the state of our work. Be sure that in near future, we'll be back to show you advanced results in our research.